So let's take a look at our first example, and that's depositing money into a bank. Okay, so let's say that Sarah gets $350 for Christmas, and on January 1st, she's going to deposit all of her gift money into a savings account at her bank. The account pays an annual interest rate of 0.4%, and that's compounded daily. So we want to know how much interest will Sarah have earned after 1 month. Okay, so if we want to know what that's going to be, we know that it's a compound interest question. So we need to figure out, well, what's the compound interest? So this is actually a compound interest question. So we want to figure out what's the final amount going to be, what's the principal going to be, what's the interest rate, and then what's the time, the number of compounding periods that are involved in this particular investment. So we don't know what the final amount's going to be. We know that the starting amount is $350. We want to figure out our I value, and that's going to be the rate of interest divided by the number of compounding periods. So if she's investing it in January there are 31 days. Okay, so in January, because it's invested daily, so that's 365. Okay, and there's 31 days in January, so our I value is going to be 0.4%. Oh, I want to convert that into a decimal, actually. I haven't done that yet. So I would do 0.4 divided by 100. That would give me 0.004 divided by the number of compounding periods per year, which is 365. And then I'm going to do 0.004 divided by 365. And that's going to give me, I'm going to round this, approximately 0.004. Uh, 0.0011. Okay. Oops, let's make this go away. Okay. So I'm going to approximate that. Okay. And then T is the number of compounding periods invested. So I know that it's compounded daily, but I only want to figure out how much she's earned after a single month. So in the month of January, there are 31 days. So that means that there's 31 compounding periods in total. So I'm going to plug this into my future value formula. So I've got A is equal to P times 1 plus I to the exponent N. So A is equal to 350 times 1.000011 to the exponent 31. And so I'm going to get 1.000011 to the exponent 31 times 350. So at the end of 1 month, her total value is $350.12. Okay, so if I want to figure out the total amount of interest that she has earned, okay, then what I need to do is take my amount. Okay, so your interest is equal to your interest is equal to your final amount minus your principal. And so in this case, my amount is 350.12 minus my principal of $350. So after a single month, she has earned a whopping 12 cents in interest. Okay? So let's take a look then at the second part of this question. How much interest will Sarah have earned after 6 months or 183 days? So everything else stays the same. My A value is still unknown. My principal is still $350. My I value is 0.000011. And this time, instead of it being in the bank for only 31 days in the month of January, let's say after 6 months, it's been in there for 183 days. So 183 compounding periods. So let's plug that into our equation. So A is going to equal to P, which is 350, times 1 plus I. So that's going to give us 1.000011 to the exponent 183. So again, if I calculate this, 1.1234 to the exponent 135 times 300. So after 6 months, she will have $350.71. Okay. So again, if I want to figure out how much interest she's actually earned after 6 months, I would do my formula for interest. So I is equal to A minus P. A is going to be 350.71. P is 350. So the amount of interest that she's earned after 6 months in the bank is 71 cents. Okay.